Hi, we shall be talking about the association between R square and F statistic. Suppose in I and F is the inflation and UNE is the unemployment and GDP is the gross domestic product. For today's lecture, I have taken the sample from 1960 to 1990. We have 31 observations. Our dependent variable is the GDP and the independent variable is inflation and the unemployment rate. Let's estimate. So go to the quick estimate equation. First write down the dependent variable, then constant and the independent variable, and then click OK. Here is the result. The dependent variable is the GDP and the independent variable is inflation and unemployment rate. Let's check whether our independent variable is significant or not. The probability of inflation is 0.47%, which is less than 5%, meaning that this is significant because this is less than 5%. Another variable is unemployment. The probability of the unemployment is 65.8%, which is more than the 5%. So unemployment rate is not significant variable to explain our GDP. Okay, here out of these two variables, one is significant and other is insignificant. So we are happy about the model because out of the two model, one is significant. And what is the guideline? The guideline it is at least 50% variable should be significant to have a good regression model. 50% or more than 50% or more variable should be significant to be a good regression model. And let's talk about our main issue, R square. And what is R square? We call it joint test. The value of R square is how much? 25.33%, meaning that of this I can say that 25.33% variation in GDP can explain by our two independent variables such as inflation and unemployment are jointly. Another way we can also say that the 25.33% fluctuation of the GDP can be explained by our two independent variables. And the rest what is called? What is the meaning that 100% minus 25.33%? Meaning that almost 74%, right, are explained by the outside the model, whereas the 26% are explained by the inflation or unemployment, and rest of the fluctuation, that is 74%, are explained by the outside the model. So meaning that our model is not nicely fitted because the 25.33% is very low. So let's talk about the F-statistic. Here we can see that the F-statistic value is 4.750 and the probability is 1.6%. The probability shows that this is significant because this is less than 5%. The probability of F-statistic is 1.6%, which is less than the 5%. When we talk about the only one variable, the T statistic, there's only inflation was the significant. But when we talk about the F statistic, it tells that the jointly independent variables are the significant. Our both variable are jointly are significant. So most of the statistician are agree that if the R square is not nicely fitted, but the F statistic is the significant, so our model are stable. I tell you again, most of the statisticians are agree that if the R square is not nicely fitted, but the F statistic are indicate the jointly significant, so our model are stable. If we talk about the relationship between, look at the formula of F test and of F test. This formula indicates that there is a positive relationship between the F and R. If the R square is increased, so F statistic is also increased. Suppose if we take the one independent variable, the case indicate the how many dependent variable you have in your estimate equation. If you take the one independent variable, so you will write k1. So as the independent variables increase, so F statistic also decrease. So there is the inverse relationship between the independent variables. As you increase, so F statistic will be decrease. And I tell you again that there is positive relationship between the R square and F statistic. If the R square is increased, so F statistic will also increase. So guys, if you like my video, so kindly subscribe my channel. Thank you.
हेलो अस्सलाम वालेकुम जी। पिछले लेक्चर में मैंने आपको बताया था कि अगर रिसेशन हो या पॉजिटिव ऑटो कोरिलेशन हो, उसको कैसे हैंडल कर सकते हैं। इस वाले वीडियो में मैं आपको बताऊंगा कि हाउ कैन वी फोरकास्ट बाय डायनेमिक, बाय स्टैटिक, बाय डिटर्मिनिस्टिक एंड बाय स्टोकेस्टिक। सो सबसे पहले मैं आपको बताता हूं कि हम डायनामिक फोरकास्ट कैसे कर सकते हैं। तो हमने फोरकास्ट पे जस्ट क्लिक किया। फोरकास्ट पे क्लिक करने के बाद यहाँ पे एक ऑप्शन आता है डायनामिक एंड स्टैटिक। यहाँ पे जिस तरह है RGDP अंडरस्कोर फीजी डेटसेट्स, ये बिल्कुल ठीक है। आज के आगे आप लिख दें थोड़ा इसको अलग डिस्टिंग्विश करने के लिए OD कर दिया आपने, ठीक है जी। यहाँ पे आपने जो एयर सिलेक्ट करना है तो मैं अपने हिसाब से कर रहा हूँ 2011, 2020, 2013, 3 साल का मैं अपना सिलेक्ट कर रहा हूँ डाटा एंड देन ओके। ये रूट मीन स्क्वायर एरर है, ये मीन एब्सोल्यूट एरर है, मीन परसेंटेज एरर है। इन सब में से जो मैं अक्सर यूज़ करता हूँ RMC, रूट मीन स्क्वायर एरर। मीन से अगर आप 5-6 फोरकास्ट को कंपेयर करें जो हमने अच्छी फोरकास्ट की, उसमें से सबसे कम जिसका एरर आए आप वो वाली फोरकास्टिंग आप चूज कर लें, वो आपकी सबसे बेहतर फोरकास्ट है। इट्स ओके। अब नेक्स्ट ये है कि आप अपने टेबल में जाएं, वर्क फाइल के, ये आपका है OD फीजी जो फोरकास्ट है, और ये आपका रियल GDP फीजी। इन दोनों को आप कंपेयर करें। इसको आप ग्रुप बनाएं। अब आप इसको नीचे लाएं और 2011 टू 2013 जो हमने फोरकास्ट किया है ये वाली वैल्यू देखें, ये वाली वैल्यू 2011 4.932, ये 5.0। अगर आप इसकी ग्राफ चेक करें, लाइन सिंबल, और ये इसकी ग्राफ ब्लू के अंदर एक्चुअल है, रेड के अंदर फोरकास्टेड वैल्यू है। और अगर इसकी आप थोड़ा इसको 2011 तक लेकर आ जाएं ताकि ये ज़्यादा अच्छा नज़र आए। ये 2000 है। ये आपकी एक्चुअल फोरकास्टिंग। रेड फोरकास्टिंग जो रेड से है वो आपकी फोरकास्टिंग वैल्यू है, ग्राफ है, और ये ब्लू वाली एक्चुअल। अब नेक्स्ट आपके पास है स्टैटिक फोरकास्ट। स्टैटिक फोरकास्ट के लिए जस्ट आप ये करना है, यहाँ पे स्टैटिक में क्लिक कर दें और आगे आप लिख दें OS, और यहाँ भी आप वही पीरियड ले लें 2013 2011। हम सारे फोरकास्टिंग को बेसिकली कंपेयर करना चाहते हैं। तो ये इसकी आ गई फोरकास्टिंग, और इसकी रूट मीन स्क्वायर एरर भी आप अपने पास एक जगह नोट डाउन कर ले जब आप अपने लिए कैलकुलेट करें, और फिर हम चेक करें सबसे जो जिसका कम रूट मीन स्क्वायर एरर है आप उनको लें। अब ये चीज़ आ गई आपकी OS या आपको स्टैटिक। इसको भी आप ग्रुप बना के चेक करें और इसका भी आप ग्राफ चेक करें। ग्राफ इसका ये रहा, इसको नीचे से करके यहाँ ले आए और ये इसका ग्राफ है। बजाय तौर पे दोनों सेम लग रहे हैं, लेकिन जिसका एक्चुअल फैसला मीन स्क्वायर एरर करते हैं कि आप कौन सा लोगे। स्टैटिक और डायनेमिक के अंदर आपको एक चीज बताता चलूं कि स्टैटिक आप उस वक्त यूज करते हैं जब आपका एंडोजीनियस वेरिएबल नोन हो, और डायनेमिक आप उस वक्त यूज करते हैं जब आपका एंडोजीनियस वेरिएबल आप फोरकास्ट वैल्यू आप यूज कर रहे हो। ठीक है जी, इसको मैं डिलीट करता हूं। अब दोबारा एस्टिमेट में आया, इसमें आया, ये आपका स्टैटिक वैल्यू और डायनेमिक हमने फोरकास्ट कर। अब दूसरा हम करने जा रहे हैं स्टोकेस्टिक और डिटरमिनिस्टिक। इसमें गए, सॉल्व में क्लिक किया, ये डिटरमिनिस्टिक। इसके अंदर भी बेसलाइन वैल्यू जैसे डिफॉल्ट है बाय डिफॉल्ट आप इसको ऐसे ही रहने दें, और ये 2011 से लेके 2013 हम इसको भी बना लेते हैं। ठीक है जी, और ये इसका जो वैल्यू आई है वो RGDP फीजी। ठीक है, आप साथ ही साथ इसको भी कंपेयर कर लें ताकि हम डिटरमिनिस्टिक भी कर लें। डिटरमिनिस्टिक हम कर चुके हैं, अब हम स्टोकेस्टिक करेंगे। यहाँ पे गए, सेव में गए, और 2011 से 2013 हमने तीनों हमने काउंट कर ली। डिटरमिनिस्टिक O से शो हुआ है, स्टोकेस्टिक OM से आया है, ठीक है, OS से आया है, कैपिटल O से। ठीक है, आप इन तमाम वैल्यू को आप एक जगह ग्रुप बनाएं जैसे हमने पहले बनाया। और अब आप इसको कंपेयर कर लें, कंपेयर करिए, और जो ये आपके सारे फोरकास्टिंग वैल्यूज हैं आप इनको अपने रिसर्च में आप इस्तेमाल करें, आपको ज़्यादा फायदा होगा। ओके, थैंक यू। इंशाअल्लाह अगली वीडियो के साथ मुलाकात होगी। फवाद।
I'm going to show you how to apply Houseman test. I have my E-views file open here, and these are my variables. Liquidity is a dependent variable and rest all are independent variables. So before applying Houseman test, we first have to change the data into panel because this is undated, unstructured data. So before applying Houseman test, we have to convert it into panel data. For converting the data into panel data, go to proc, click on structure resize current page, and select the work file structure type as dated panel. So in frequency, if your data is annually, so insert annual here, and in this box insert your starting date of your data, which is in my case is 2006, and the ending date is 2013. Now in cross section ID series, I'm gonna put forms because I have given the name it as a forms, and as in date series, give the name of your time series, or the name of your date series, which is year in my case, and then press OK. So now it is seen that our data has been converted into panel data. Now we can apply Houseman test. So for doing that, go to quick, select estimate equation. First insert your dependent variable, then C, then all independent variables, which are FS, investment, leverage, net working capital, ROA, and sales growth. After inserting all the independent and dependent variables, go to panel option, and from period select In this video, I'm going to show you how to test heteroscedasticity in the data using E-views. But before doing that, let's see what is heteroscedasticity. So heteroscedasticity is present in the data when the size of error terms or the residuals differs across the value of an independent variable. For example, a low-income families spend less on luxury items, while high-income families spend more. If we combine these two categories as a data, then we will have the problem of heteroscedasticity. In this graph, if we move further, we see that the distribution or the data spread is increasing, and it makes a cone-shaped graph. It means that there is a heteroscedasticity in the data. If we apply some test on this data, we will have some spurious results. The results will be incorrect. Likewise, if we see this graph, the distribution is not similar. If we have such type of distributions or such type of data, we will have a heteroscedasticity in that data, and if we apply some test on this, then we will have some incorrect results. Due to a heteroscedasticity in the data, we will have a biased standard error and spurious results, and as a result, we will have an incorrect conclusion about the significance of regression coefficients. Because if the standard error is not correct, or if it is biased, then the result or the value of regression coefficient differs, and as a result we will have some different and incorrect results. To eliminate heteroscedasticity from the data, different techniques are used, but two most commonly used techniques are weighted least square and transformation. Now let's see how to check heteroscedasticity in the data using E-views. I have a E-views file open here, and this is my data. I'm going to apply a regression test on it, and then I will check whether heteroscedasticity is there in this data or not. So first of all, I have to create a work file by writing a W from this code section here. And then I have to create an unstructured work file, and I have 472 observation. I have to enter 472 observation here and then click OK. These two fields are optional, so no need to fill this out. Now I have a new work file. Now I have to create some variables like liquidity and WC net working capital, leverage, investment, sales growth, ROA, and font size. So after creating that, we can easily import data into this file by just selecting the data from the Excel sheet and copy here and directly paste here. So we have successfully imported data from Excel sheet into E-views file. Now if I close this, so we have no problem because we have already stored our data into concerned variables. Now I'm gonna apply regression, simple regression or multiple regression, and now these are independent variable. Liquidity is liquidity is our dependent variable, then C, then FS, investment, leverage, net working capital, ROA, and sales growth. After entering all the independent variables and dependent variable, click OK. This is our regression result, in which it shows that there are 4 significant variables and 2 insignificant variables. The R-square value is 47.46%, which is good. It's not that much bad. But now the next step is that how to check whether there is a heteroscedasticity in this data or not. So for this, click on the view of this window, go to residual diagnostics, and then heteroscedasticity test. So for this, I will select Bruce-Pagan-Gottfried test. This is a list of variables, and now click OK. So here, the probability value of chi-square is 0.000. It means that this shows a significant result. It means that the null hypothesis rejected and the alternative hypothesis accepted. So what does null hypothesis is? Null hypothesis is that there is no heteroscedasticity in the data, or the data is homoscedastic. But here the result shows that that statement is rejected. It means that the alternative hypothesis which states that there is a heteroscedasticity in the data is accepted. So it means that the data has heteroscedasticity. So that's all for today. Thanks for watching.
For the further videos, subscribe our channel and notify it for the further videos. Thank you.
हेलो जी, आज मैं आपको बताऊंगा कि हम अपने डेटा को कन्वर्ट किस तरह कर सकते हैं, एनुअल को मंथली में, मंथली को क्वार्टरली में, या एनुअल को क्वार्टरली में। हमारे पास ये जीडीपी का डेटा है और ये डेटा हमारे पास एनुअली डेटा है। अब इस एनुअली डेटा को हम किस तरह इसको दूसरी फ्रीक्वेंसी में चेंज कर सकते हैं। ठीक है जी, तो सबसे पहले हम इसको चेंज करते हैं इनटू क्वार्टरली फॉर्म। सबसे पहले इसको कॉपी कीजिए, न्यू पेज में क्लिक करके स्पेसिफाई द फ्रीक्वेंसी रेंज। यहाँ पे एनुअल को क्वार्टरली आप सिलेक्ट कीजिए और देन ओके। अब यहाँ से जो कॉपी किया था यहाँ पे पेज स्पेशल कर दें, यहाँ पे लीनियर सिलेक्ट कीजिए और इसको यहाँ क्लिक कर दीजिए एंड ओके। अब आप देखें कि आपकी जीडीपी एनुअल का डेटा ये क्वार्टरली फॉर्म में कन्वर्ट हो गया। अब इसी तरह अगर आप चाहें तो आप क्वार्टरली को एनुअल में भी लेकर आ सकते हैं। जिस तरह हम एनुअल को क्वार्टरली में लेकर गए हैं, क्वार्टरली को हम एनुअल में लेकर आ सकते हैं। देखें आपके ऑब्जर्वेशन भी इंक्रीज हो गई, 180 ऑब्जर्वेशन हो गए। अब हम फ्रीक्वेंसी रेंज में जाके क्वार्टरली को अगर मंथली में कन्वर्ट करना चाहे ये भी कर सकते हैं। ओके क्या कीजिए, यहाँ पर पेज स्पेशल स्पेसिफाइड रेंज में लीनियर क्लिक कर दीजिए एंड देन ओके। अब आप देखें आपकी ऑब्जर्वेशन इंक्रीज हो गई 540 और ये जीडीपी का आपका डेटा इनटू मंथली फॉर्म। इसके आप ग्राफ भी चेक कीजिए, मंथली फॉर्म का डेटा का, ये क्वार्टरली डेटा का, और लास्ट में एनुअल डेटा का। अब आप इसको कंपेयर करके देख लें कि एनुअल, क्वार्टरली और मंथली में क्या फर्क है। ये एनुअल, ये क्वार्टरली, ये मंथली। और मज़ीद वीडियोस के लिए आप हमारे चैनल को सब्सक्राइब कीजिए। थैंक यू फवाद अकेडमी।
In this clip, we are going to estimate a vector autoregressive model for a system of 3 series here. The data we have in this E-views file are the French, the German and the US long-term government interest rates. So let's firstly have a look at these. You should always have a look at the data. So we open all of the 3 series as a group, and you can see these are interest rates expressed in percentage points. And let's have a quick look at the data. We'll have a line graph, we have multiple series, but we'll put them in one graph. And here you can see the series, and what you can see is that they generally move together, especially in the latter part of the series. In the 80s there was a period where they didn't move that closely together, although the general tendency still matched more or less. So what we are now going to do is to estimate a simple var1 model for all of the series. We can delete this graph, delete the group. Yes, so we have our 3 series highlighted, and what we now going to do is we're going to highlight the US, and the ordering will matter very soon. So we're going to do the ordering US, Germany, France, and we open this as a var. So here we can specify the var. We have our three series here. So we'll firstly have a quick look at the var in levels, although we know they are non-stationary, we possibly shouldn't do that. And we do var with one lag. So what we do is the first lag is 1, the last lag is 1, so that's a var 1 1, and we have a constant, and we click OK, and we get some var. And you can see already that the lag for the US long rate, the 1 period lag for the US long rate, the own lag, is very close to 1. It's the same for the Germany and for the French series, so that possibly indicates that that's a possible indication that we have non-stationarity here. So what we are going to do is we will want to estimate this for stationary series, so the first differences, and it's very easy. You just put a D and then parentheses around your series, okay, and that will tell E-views that you want to actually use the first differences. You could of course also first create the series and give them new names, the different series, and then apply the var to these series. So we press OK. You see we get very, very different coefficients. Now since let's see how many coefficients we have. We have 3 variables, that means we get 3 columns, one for the coefficients in the US equation, one for the coefficients in the Germany equation, and one for the coefficients in the France equation. In each equation we have, let's see, 4 coefficients. We have the constant down here in the bottom, and then we have the 1 period lags in the US equation, 1 period lag, the own lag, the US lag, 1 period German lag, 1 period French lag. Okay, and we have the same for the Germany equation and for the French equation. Let's have a look at which coefficients are significant. Let's firstly see what information we are given. In parentheses we have standard errors, in square brackets we have the t-stats, so we'll look at the t-stats. And we'll firstly see that the coefficient to the 1 period US lag is significant certainly in the US equation, certainly in the Germany equation, and certainly in the France equation, all with very significant t-stats, way larger than 2. So the 1 period lagged change in the US long-term rate has an influence on this period's changes in all. No, that wasn't meant to be there. Has an influence in this period's changes in all 3 equations. Now let's look at the 1 period German lag. Turns out this is only significant in the Germany equation. Okay, so the change in the German long rate from 1 period ago only has an influence on this period's rate change in Germany. And last period's French change in the long rate interest rate is not significant anywhere. Okay, so we don't actually need that last element to explain the variation in today's changes in the long rates. What we shall do next is to establish whether the fact that we used var 1, so 1 lag in the vector autoregression model, whether that was sufficient to basically capture the dynamics in the changes of our interest rates. The way to do that is to do a test on the residual autocorrelation. If that 1 lag is sufficient, then we should find that the residuals aren't autocorrelated anymore. So the 1 lag of the changes in the long rates capture all the dynamics. So we'll go to View, Residual Tests, Autocorrelation LM Test, and let's use lags of 2. So what we get here is 2 tests. This first test tells us whether the first order autocorrelation is significant, and this test tells us whether the second order autocorrelation is significant. So what we see is basically that both we have p-values tiny or very close to 0, certainly smaller than any of our usual significance levels. So that means that there is certainly first and second order autocorrelation in the residuals of the var 1 model. That means the var1 model by itself wasn't sufficient to capture all the dynamics. So now that we've established that a var1 is most likely not sufficient to model the dynamics, what we shall do now is to see whether we can find out what lag order we should use. So we go to View, Lag Structure, and we go to Lag Length Criteria. And let's select 4. We'll let E-views choose between var models up to order 4. And this is the table we get. Okay, so it's the table with our information criteria. And let's see what we can find here. We have all sorts of different criteria here. Let's only look at the Akaike and the Schwarz criterion. These are the ones we are familiar with. And we can see that the Akaike criterion selects a lag order of 3. Okay, that's where we can find the asterisk. It's the smallest value of that particular information criterion. And the Schwarz information criterion selects a lag of 1. Now between these two, which ones would we choose? Well, we've already rejected a lag order of 1 because we looked at the residual autocorrelation and decided, well, there clearly is leftover residual autocorrelation. So that by itself would let us decide possibly go for a lag order of 3 here. So let's estimate a var3. Go back to the estimation. We change our maximum lag from 1 to 3. Everything else remains unchanged. We estimate the model. So here we go. Now we have for each equation, we have 9 lag coefficients and 1 constant. So for each equation, we'll have 10 coefficients. Let's not look at the coefficients themselves too much. You can still see that the first set of coefficients relates to lags of the US, of the changes in the US long rate, and they are still, the first lag is still significant for all 3 equations. The second lag is significant for the US equation, and we could look at that in detail. What I now want to look at is whether there's any issues about the non-stationarity of the system or the stability of the system. What we'll do is we'll go to View, and we shall go to the lag structure and to the AR. That's starting to be a bit annoying. And lag structure and to the AR roots table. Okay, and what we see here is all the roots of our system. And what we are looking at here is the absolute value. We may have complex roots. What we are interested in is the modulus, which is sort of the absolute value of a complex root. They are all smaller than 1, all inside the unit circle. That means this system is stationary. So there's no problem with non-stationarity. Of course, you could try yourself and estimate that var model on the levels, not on the changes of the interest rates, and you would find a different picture. So, of course, now that you have chosen a var3, you could check the residual autocorrelation again, and you would hope that most of that is captured and has by the 3 lags included in the var. So hoping that there's no residual autocorrelation, I leave that up for you to test yourself. Now what we're now going to do is we're going to move to the interpretation of this var system, and you will have learned that the main tool to do this is to use impulse response functions. Okay, so how do we do that? In E-views there's a little button called impulse. That sounds alright. So we'll click on this. Now there's a number of things you need to do on Node. Firstly, let's not use standard errors. That just makes the graphs cluttered. You can switch on the option and see what happens. You get standard errors for the impulse response functions. We'll choose none. Now if you go to impulse definition, this is where all the magic happens. You will have learned that what we usually do is the Cholesky decomposition, and what is important is in which way we order that decomposition. Here we'll order it from US first to Germany, then France. Okay, even if little Anton doesn't like it. Cholesky ordering US, Germany, France. Let's let E-views do its magic, and here we got our impulse response functions. Let's have a look at this. So what you can see here, one thing I don't quite like about these impulse response functions in E-views is the labeling of the x-axis. It would be better if it's at 0, 1, 2, 3, 4, 5, and so forth. But hey, it does most of the work for us. We're not going to complain. So you can see there are some impulse response functions that are characteristically different, have very different characteristics. Some have non-zero values right from the start in lag 0, which is labeled 1 here. Others start at 0, like this one, and this one. Now it turns out these 0 values for the immediate or contemporaneous responses to shocks are imposed by the Cholesky decomposition, by the particular ordering. So let's look at that in detail. What we have is, in the first row, we have the responses of the change in the US long rate to first shocks in the change of the US long rate, then shocks in the change of the German long rate, and then shocks in the change of the French long rate. The second row will give us the responses of the change in the German rate, first to shocks in the change of the US rate, then to shocks in the change of the German rate, and then to shocks in the change of the French rate. And the last row gives us all the impulse responses for the French rate, or for the changes in the French rate, first to shocks in the changes of the US rate, then to shocks in the changes of the German rate, and then to shocks in the changes of the French rate. So we ordered US, Germany, France. What that implied is that we ruled out that the US rate, or the change in the US rate, would be contemporaneously affected by shocks to the German or the French rate, and therefore this graph, and I didn't want to click on this graph and this graph we forced to start at 0. Then the second country was Germany. That meant that we ruled out that changes in the German rate would instantaneously or contemporaneously be affected by shocks to changes in French rate, and this is why this graph starts at 0. Okay, so this is what the Cholesky decomposition imposed, that we start at 0. The rate afterwards, the impulses can become non-zero. So what do we see? In the first column we see the responses of the 3 series to shocks in the US rate, and we see that all of them respond positively. Okay, so immediately, if there's a shock in the US rate, the changes to the US rate, this will of course have an immediate effect to the US rate by definition, but it will also have an immediate effect on the German and the French rate. What about shocks to the German rate? We said this was ruled out to have an immediate effect, and even subsequently shocks to the German rate don't seem to move the US rate. Okay, it just stays basically at 0. Of course we have an immediate effect by the German rate, and indeed the French rate seems to react to German rates changes as well, or shocks in the changes to the German rate. Now shocks to changes in the French rate, really they stay in France. Neither the US nor Germany seem to react to those. So you would have learned that the ordering of the Cholesky decomposition is quite crucial, and of course you saw that here already because we enforced these 0 starts for the impulse response functions according to the ordering. So let's go back to the specification and let's change the ordering. So we'll leave Germany in the center, but we exchange the US and France. So US will be last and France will be first. Now we click OK, and we can see that we get quite some change. Firstly, let's see what we have imposed with this Cholesky decomposition. We still have in the first row we have the US equation, second row Germany equation, third row France equation, first column responses to US shocks, second column responses to Germany shocks, and third column responses to French shocks. Now what you can see is we previously had both Germany and France instantaneously responding to US shocks. This has now been ruled out because the US has been ordered last. That means we now have zero immediate effects of shocks to the US, changes in the long rate to the German and the French equivalents. However, and that is different to the previous ordering we had, now you can see a noticeable increase of the impulse response functions after the first period. Okay, so after one period, here label 2, you can see that there is some positive response now to US shocks both in Germany and France. Now what you can also see is, now that we changed the order, we can now see that, for instance, the response of Germany to shocks in France, we are looking at this graph, second row, third column. Now there's a noticeable positive response of the German market to shocks in the French market. We didn't see that before, although it wasn't imposed to be equal to 0. Okay, so that is clearly another difference we can see. So without doubt, the ordering is very, very important, and you need to think a little bit about which one makes sense. And I think, given the importance of the US, the German and the French market, it's possibly the first ordering which we used which makes somewhat more sense than this ordering. Let's go back to impulse response, and what we shall use now, instead of the Cholesky decomposition, we now use as decomposition method the residual decomposition method. Now what that means is, you can see the ordering is disabled, we don't need that anymore. This implicitly assumes that there is no contemporaneous correlation between the residuals. So the impulse response functions, which we will see very soon, as soon as we click OK, will be correct if that's true. However, they will be seriously misleading if there is contemporaneous correlation between the residuals in the three equations. So let's click OK. And what you can now see is that basically the following. Firstly, you can see that we have clearly positive effects in the own countries. So in the US to shocks in the US, in Germany to shocks in Germany, and to France to shocks in France. That's not surprising. And you can see that all off-diagonal impulse response functions start at 0. And of course that is imposed because we said we assume there is no contemporaneous correlation. There's no correlation between the residuals, so by definition there's no response of the German market to shocks in the US contemporaneously, because remember, the var itself will only respond one period after, because we're having the 1 period lags, the 2 period lags, and the 3 period lags. So contemporaneous shocks can only come through the residuals. And we ruled out any correlation, so therefore all these off-diagonal impulse response functions will be 0, and in general they all seem to be very small. If at all, we can see somewhat positive responses to US shocks again. So it looks very much, these ones look very much like the Cholesky decomposition, the second one we had, but there's other changes here. So this is all I had to cover in this clip.
renderforce.com. renderforce.com.
If you like our video, then subscribe our channel and also click on notification for the next video. Hello guys, in this video I am going to tell you about the cointegration and error correction model. In order to find the cointegration, there is some necessary condition, like all the variables are stationary at first difference. And for vector error correction model, if there is cointegration error exists, then you will choose the vector error correction model, otherwise vector autoregressive. In this video we are going to explain about lag length criteria, because most of the students are confused about how many legs should we choose in our equations. So we will remove the confusion in this video, kind of. In this lecture we have 4 variables. Look at these 4 variables. All the variables we have converted into the log form except interest rate. The first one is money, second one is consumer price index, and third one is industrial production. In industrial production there is some seasonality issue. So in order to remove seasonality, we have used some procedures. Moreover, if you need any data regarding the lectures, so you can email me my respective email ID, which is shown in this video. Look, there is the variable, there are the variables, and we have converted already into the log form. Let's check the graph of the consumer price index, industrial production data. Go to the view, click the graph, and the log of money. Look at this. Out of all variables, there is only industrial production data in which the seasonality problem has been visible. So in order to remove the seasonality, we will click PROC and go click to season adjustment and click on census X12 and click OK. Change the name. Now check the graph. Go view, click graph, click OK. Look, the seasonality problem of the industrial production has been removed. Compared with the previous one, look, seasonality problem has been removed. Now the next step to find the lag length. Before go to cointegration, first of all find the lag length criteria. Just go into the quick estimate bar, write down the dependent variables LM first and then independent variables LCPI R. Click OK. Then go to the view, Click lag structure and the lag length criteria. Click OK. The static shows that we can take 5 lag out of 8. We can take 5 lag. This is the length of our equation. We can take 5 lag. Let's check the exclusion out of 5 lag. How many lag can we exclude? Just click on estimate, write 1 to 5 instead of 2 and click OK. Then go to the view, lag structure, lag exclusion test. Out of 5 lag, the lag 3 shows that insignificant. This is a F test. The lag 3 shows that insignificant. So we can remove lag 3 out of this 5 lag. So our actual lag is lag 1, lag 2, lag 4, lag 5. Because lag 3 is insignificant, so that's why we have removed from our model. Now check the co-integration after finding the lags. Open as a group, view, co-integration test, Johnson system test, and click and mention the lag as we have decided 1, 2, 4, 5. Click OK. This is a 2 co-integration test, trace test and maximum agent test. And the trace test indicates one co-integrating equation at the 0.005 level, and the same as true for the max eigenvalue. It means that the r equal to 1, meaning that the co-integrating equation exists in our model, meaning that there is long-run association between among variables. So we can select the vector error correction model instead of vector autoregressive because there is co-integrating equation exists in our model. So go to the vector error correction model, click open as WAR, select vector error correction model, mention the lag 1, 2, 4, 5, click co-integration, the number of co-integrating error is equal to 1 and then click OK. This is our long run equation. The minus sign shows that there is a positive association between the consumer price index and the money supply, and the minus sign shows that there is positive association between money supply and industrial production, and the positive sign shows that there is negative relationship between the interest rate and the money supply. The interpretation always be opposite because there is equal sign between the dependent variables and the independent variable. This is a long run equation. So yes, how about this interpretation? How can you interpret these values? We are interested on this vertical line because this is our dependent variable money supplies and these all are independent variables. And this co-integrating error, it shows that speed of adjustment. And how can you interpret these values? Look at these PowerPoint files. In response to some shock which disturb long-run equilibrium, some or all of the system variable should adjust to restore equilibrium. If Lm is greater than these values, which are long-run equation, then interest rate falls and output and inflation will increase to restore equilibrium. Interest falls because interest has negative relation between these values, and CPI and LIPSA, industrial production, have positive relation. So interest will fall and output and inflation will increase to restore the equilibrium if the condition Lm is greater than. And what about these values, which is called the speed of adjustment? In money stock, each quarter 8.7% of the discrepancy from the long run equilibrium is corrected. These adjustments are though not rapid but is statistically significant. For restore the equilibrium, this is necessary that the sign should be negative and the coefficient should be the significant. If the value is significant and sign is negative, so meaning that it will be equilibrium in long run after every shock. Why we read the quarter? Because our data is quarterly, so that's why we have written that in money stock each quarter 8.7% of the discrepancy from the long run equilibrium, meaning that in every quarter the shock will be adjusted automatically. So this is our this is the interpretation of this. Now how can you, so this is the long run equation, this is the speed of adjustment. Now question that how can you calculate, how can you find the short run causality, means whether the consumer price index, the inflation, will cause the money supply in short run or not. So the procedure is to find the causality is very simple. Go to proc, make system, order by variable. This is about the dependent variables. So first of all, copy it and go to quick estimate equation and then paste it. This C1, it shows the speed of adjustment of the long run equation. If any shocks occur in the future, so it will be adjust 8.7% rate. And these all variables are the independent variables. Now we want to find the causality between the short run causality between the consumer price index and the money supply. So first of all, check the coefficients of the inflation. What are the coefficients? Number one is C6, C7, C8, C9. C6, C7, C8, C9 are the coefficient. Go to the view, coefficient diagnostic tag, volt test. Write down C6, and then OK. The F-statistic shows that this is a significant answer, meaning that in short run inflation will cause the money supply positively. Money supply inflation will cause in short run to money supply, means there is a causality, means there is a short run relationship between the inflation and the money supply. The same is true you can find for the industrial production and for the interest rate. And moreover, you can also find the relationship between money supply and consumer price index for the long run and for the short run as well, because you have these equations. And you can also make the industrial production as a dependent variable. So look at this PowerPoint file. This is our dependent variable and these are the independent variables, and this is the speed of adjustment for the money supply, whether it will be adjust after every shock or not. So you can also find for this consumer price index, for the industrial production, and for the interest rate. Look at the relationship between which I have calculated already. The relationship between the consumer price for the money supply and the consumer price index is this significant, meaning that in short run inflation will cause the money supply. Industrial production will not cause the money supply because it's insignificant. Interest rate, it's also not cause the money supply because it's also insignificant. And the speed of adjustment is the significant, and the negative sign, it's meaning that it will be adjust in the future. You can also calculate for these respective variables. If you need any data, you can email me, which is given in this marquee line. Thank you. So guys, this is our uh, today lecture. If you want to ask any question, you can email me, and you can also write in the comments box, so I will reply in future, inshallah. Okay, thank
Renderforce.com. renderfocus.com.
If you like our video, then subscribe our channel and also click on notification for the next video. In this lecture, we will discuss about how to find stationarity with the help of graph. As you know that there are two essential conditions about stationarity in every graph. Mean equal to 0, variance constant. If one of them absent, so we will declare as not stationary. So let's consider this is our GDP data. This GDP data started from the 1961 to 1999, and the rest of the year are shows the not applicable, means there is a empty, meaning that we will forecast either using the ARMA or ARIMA procedure. So before all of these, first of all, we will discuss how can we find stationarity with the help of the graph. Most of the person are very well known about to check stationarity with the help of ADF test or the free parent test. But there are most of the students who are the confused to check stationarity when they see the graph. So let us start it. This is our GDP data. The GDP data is started from 1961 to 1999. Let's make it graph. Line. So this GDP data, it shows that the mean is not 0 and the variance is also is not constant, and there is the upward trend. How can we check the trend, whether there is a trend or not? Intercept, it's all clearly indicate that there is the intercept, but how can we check either there is a trend or not? So this is a very simple procedure. Write on command ls gdp constant c at trend. If the trend coefficients, it shows the significant, so meaning that there is the trend. If it shows that insignificant, so meaning that there is not a trend. So most of the theories indicate that if we take the log of any variable, so we will stabilize our variance. So let's take the log of our GDP data. It's very easy procedure. Just write the series LGDP log GDP. Sorry, GDP. So this is we convert the GDP into log form. Let's check the graph. Look, there is the intercept as well as there is a upward trend, and variance is stabilized kind of. How can we find whether the variance is stabilized, means variance are decreased or not? So this is a very easy procedure as well. Just write add VAR, means variance, and write GDP. This is the variance of the GDP. Write down in one page. And what is the variance of log of GDP? It's very simple procedure. Just write add var L GDP and click it's okay. So this is the variance of log of GDP. If we want to say about the variance of log of GDP or the GDP, so this is very easy as well. Just write the scalar k. You take the any variable. I taking the k. K is equal to at var GDP. So it's indicate the variance of GDP. Same as write another variable k1 and take the variance of log of GDP. So this is indicate the variance of log of GDP. So you write in the one page and then compare which variance are the lesser. So it's clearly indicate that the variance of the log of GDP is quite lesser. So in order to check that there is trend or not, just write ls LGDP C at trend. So log of GDP is also include the trend. In order to forecasting purpose, you have to remove the trend from your variable. So let's take the first difference of the GDP. Series DGDP is DGDP. This is the first difference of DGDP. Let's take the graph of it. Look at this graph. Mean is not 0, as you show that there is quite 4000, and the variance, it's also very variation in it. Let's check the graph too in order to check the easiest way. For the mean, you can also estimate by the numerical way. Write the mean, add mean DGDP. It shows that 14,293. This is a mean. Means it's not equal to 0. So that means it's not a way. It's not a stationarity. And if you want to check the variance, so variance var DGDP. Variance is quite the higher value, means that it is more than the log of the GDP variance. So meaning that there is not stationarity when you take into the first difference. So let's take first difference of the log of GDP. Series DLGDP DLGDP L. Now check the graph of it. Sorry. Look at this graph. The mean is approaches to 0 and the variance is also stabilized. Let's check. So let's check in numerical way. Let's check first mean. Mean at DLGDP. It shows that 0.005. It's not equal to 0, but it approaches to 0. So means that the mean is 0. And for the variance, means variance is also it's very small, 0.00. So write down in one page and compare which variable mean is 0 or approaches to 0 and which variable variance is small. Yes, so this is our variable GDP, write mean and the variance, and this is our DGDP, that the mean and the variance, log GDP mean and variance, and D log GDP mean and variance, and compare all of it. Pause this video and calculate by yourself. Yes, this is the answer. So D log of GDP means are small among all, and same as true for the variance. D log of GDP variance is very small, it's 0.003, meaning that the variance is constant and mean is the 0. So D log of GDP is stationarity, meaning that the log of GDP are the stationarity in the first difference. So in order to check the trend, whether there is a trend or not, so it's very simple procedure as we did before. Just write D LSD log of GDP C at trend and check the trend. So this is show that the trend shows the trend coefficient shows that there is a insignificance, so meaning that there is a no trend. So mean that we will forecast our GDP with the help of first difference of the log of the GDP, because the mean is 0 and variance is constant and there is also trendless. So how can we forecast? Through ARMA or ARIMA procedure. So when we take the first difference, so there is confirmed there is not a ARMA, because ARMA means auto-regressive moving average and ARIMA means auto-regressive integrated moving average. So when we take the first difference, so it's automatically convert into ARIMA. Fine. So first of all, we will take the corogram to check the AR lag and moving average lag, means MA lag. We go to corogram and label. The autocorrelation mean shows that moving average, whereas partial correlation shows that autoregressive. So it shows that AR4 or I mean MA4 and AR4 are one possibilities, and also MA4 AR0 it's another possibilities, and also AR4 and MA0 it's also one possibilities. So you check all of these possibilities and out of all possibilities, if the archaic AIC value and Schwarz BIC value are the small, we will take that equation. I again explain, out of all possibilities, we will take those equations whose archaic and Schwarz value are small. Okay, so this is all possibilities. This is indicates AR1 MA0. This is indicate AR4 MA0. This is indicate AR0 MA1. This is indicate AR0 MA4. This is indicate AR4 MA4, and this I take the extra AR5 and MA5. This is indicate AR1 MA4. So you write down each and every equation archaic and BIC value, means Schwarz value. Out of all of these, if the archaic value are the small and BIC value are the small, so we will take that equation. So how can we find? Go to quick estimate equation, write ls, oh sorry, write d log GDP C. First I take AR4. This is also this is already I have calculated. So AR4 and MA0 means MA0. AR1 2 4. This is an extra coefficient in E-views 9. So in order to remove it, just going to estimate, option, convert into maximum likelihood to the ordinary least square, and go to the E-views legacy and OK. So you can see that the sigma s squared is s removed. Now write it down, this value here, same as you calculate for this and calculated for this and calculated for this. Pause this video and calculate it by yourself. This is an answer, meaning that AR0 and MA4 are the smallest values among all. So we will forecast our GDP on the basis of AR0 and MA4, because the AIC value and BIC value are small among all. So let's calculate. Convert AR MA and going to the forecast and forecast the value from 2000 to 2005. Let's check the forecasted value. Let's see, we have calculated from 2000 to 2005. This is all forecasted value which we calculated from the autoregressive integrated moving average. Let's compare with the original data. This is an actual one and this is the forecasted one. SMPL at all, it shows the all values. SMPL, sorry. This is all forecasted and this is the actual. E-views 9 have the advantage to calculate autoregressive moving average automatically. How can we calculate? Okay, this is, suppose we have the as you know that this is our original data GDP. Going to the PROC autoregressive integrating moving average forecast. The log variable we have to take, because when we take the log, the variance is stabilized as we have seen before. And take the maximum difference is 1, because when we take the first difference of log of GDP, the mean is become 0 and variance was constant. And with the help of the chronogram, we have seen the maximum value of lag we have taken 4 and 4. Fine. Going to the option, click equation output table, and as you want the ARMA criteria table, and make it equation 1 and name it equation 1. Look, E-views as calculated automatically, and E-views calculated that the D log of GDP are the good estimator, and AR0 MA4 as we have calculated earlier, and this is the equation which calculated by the E-views. Go to the estimate option, maximum likelihood CLS, and E-views legacy. Click OK. Look, this E-views 9 advantage. This is E-views 9 advantage, which is calculated automatically. This is are the best equation. So I hope you like my video. If you like my video, please subscribe my channel for the next videos. Thank you.
Renderforms.com